All right. Good morning, everybody. Today we have speakers, uh, engineers at Intel, and they're gonna talk to us about their career and their journey to become an engineer. But before that, let's do a check-in. As you know, you have to check in so that your teachers know that you are here in this event. And if you have questions, this is a great questions document that you can reference to, and the evaluation form. This is very important. This is how we give you attendance and credit for attending this event. And this is a requirement for high school student to graduate in Oregon. Be fully present, pay attention. This is a good time to ask questions. You can ask questions in the chat, or you can raise your hand. And you can also turn on your camera. You are not gonna be showing up in the recording. And again, this is very important. Submit your evaluation right after this event, so everything is still fresh. And again, this is how we give you credit. So let's have the panels of engineer at Intel. So Kelly, I'll guess you'll go first.
Hi, can you give me a thumbs up that you can hear me? Perfect. So I'm Kelly Lyon. I work at Intel out of Portland, or like Hillsboro, Oregon. Since COVID started, I moved to Alaska, and now I live in Alaska, and I'm currently living in a van in Alaska, and so I just travel around. I'm able to work remotely wherever I am. So that's a fun feature of working in tech, depending on the team and the program and the company you work for, you're able to work remotely sometimes. So I used to be a software engineer. I was a software engineer for like 4 years, working for Intel, doing open source projects. That was exciting to me because everybody in the world got to see what I was doing because it's all online. Anybody contribute, anybody can see it. But now I'm in a role where I teach other software engineers new things. I always wanted to be a teacher, and maybe we'll kind of go into how we each got into technology, but I always wanted to be a teacher. And in this role, I kind of get to teach people things. I learn things and I teach them to other people through like tutorials. Have you ever Googled like how to do something, whatever that is? So I write tutorials and videos. I have a couple YouTube videos that I've made, walkthroughs, little code samples about how to use something called persistent memory. And that's what I'm working on right now.
Okay, thank you, Kelly. Let's have Deepak. Oh,
I think Deepak has fallen out of the meeting.
okay. Okay. Let's have Eugene.
Hi, everyone. Can you hear me?
Yes.
All right, let me turn on my camera really quick. Hi. You can see me as well, right?
Yes.
Hi, guys. So thank you very much for having me here today. Really briefly, I'm going to talk a little bit about who I am, what I do, what kind of problems I solve, what makes me a fit for this profession, and then a little bit about future forecast for the industry that currently I'm in. So a little bit about me. My name is Eugene Pohada. I currently work at Intel as a process engineer. I work for what we call dry etch, which is plasma etching tools. In terms of what I do, so as a process engineer, we are heavily involved with making sure that things are running right on the day-to-day. So things like troubleshooting our machines, troubleshooting our processes, just making sure that we're providing the best high quality process and product from an engineering standpoint so that we can make sure Intel shines and does what it does best. In terms of like some of the general duties that I have, a lot of what I do involves working with like mathematics, working with like engineering concepts, using a lot of the science that I learned in school to basically solve problems and to make sure that everything is going right. Something that I want to uniquely tell you guys about is I'm actually an immigrant from a different country. So I came from Bucharest, Romania, and my background and my culture, I was brought up to believe that science and math is very, very important. Um, and now, as an engineer, I have a true appreciation for this because I use science and math so profoundly to do these really awesome things, to solve these really cool problems. So, one thing that I want to tell you guys, as part of my culture and what I grew up believing, is that if you study science and math, you'll be able to do some really cool things in your future when you grow up, and when you work for companies like Intel, or NASA, or all the other really cool companies out there that rely on heavy math and science skills. Um, Going on to my next part in terms of what kind of problems I solve. Um, so one scenario that I want to mention to you guys is when you think about machines and when you think about machine behavior, oftentimes it's easy to assume that machines will just do what they're created to do, that machines will just run in cycle without an issue. But if there's one thing that I've learned, especially with like laser machines, is that sometimes they can do things which are so out of whack, um, things that we really need to troubleshoot to make sure that we're understanding, because there's so many parts to it. So, for example, in a laser, you have your emissions, you have your spectrums, you have your sources. And as an engineer, you need to understand like all the science and math involved in that process to make sure that when you're troubleshooting, that you understand everything, and that you can solve your problem. So the more math and science the more aptly able to solve your scenarios and what's going on. Okay, just a few more minutes. So what makes me a good fit for this profession? One thing that I mentioned to you guys is I come from a culture that's very heavily rooted in science and math. So being from Romania, what has really helped me out is by holding math and science to a high standard. It has allowed me, to go far and to achieve my personal goals of becoming an engineer. Um, so it's my culture, my personality that has really made me a good fit. And then the last thing that I want to do is just future forecast for the industry. So engineers are always going to be in demand. And if there's one thing that I want to let you guys know is that the semiconductor industry specifically, it's always going to need engineers. In terms of job security, you're definitely set. And not only that, but what you learn in one profession as an engineer, you can apply to all. So we have a lot of aerospace engineers. We have like a lot of mechanical, material engineers. And basically everywhere you go, you bring your knowledge, you bring your experience. So lots of great jobs. I'm definitely an advocate for engineering. Yeah, thanks for giving me a few minutes to talk about myself with you guys today.
Thank you, Eugene. So let's have Cindy.
Would you like me to present or just do a brief introduction?
You can present if you want.
Oh yeah, I would really like to. Oh, host disabled, participants sharing. So I think I need to co-host Privs.
There you go.
There we go. Awesome. Okay. All right. I will try to be brief. I'm a very visual person and I prefer to share my experience this way. So of course, I work at Intel in the semiconductor industry as a process engineer, just like Eugene. So I'm a first generation Latina. That means I'm the first in my family to really pursue college and complete my bachelor's degree. I do speak Spanish and English. I'm rough with my French, but I like to believe that I know some words. And I love shopping, thrifting, eating out, trying new things. And you can see here in the corner that I'm from Arizona. My parents come from Mexico Guerrero, and I'm the oldest out of 7 kids. So yeah. So what is a process engineer and what exactly do I do? So as a process engineer, I work in metrology, meaning measurements. And since Intel is such a big company and everything is so fast paced, we have to kind of use machines to automate everything, and we control the machines as engineers. And I work collaboratively with a lot of technicians on the floor, and I get to wear a bunny suit. So this person in the bottom, you see them in the full white suit. So in the fab, it's even more cleaner than like a hospital. So we have to make sure that like we don't bring anything from the outside world and contaminate these very sensitive materials. And basically where I work in Aloha, Oregon, we get to work on products that are not even out. So maybe these are chips that will be coming out in 5 to 10 years. So I find that very exciting, and that's why I came over here. High school and college, um, I struggled through elementary school. I wasn't the brightest kid, but I tried really hard. And in high school, I got a bunch of scholarships to go to Arizona State University. And what really helped me is that I used to go to summer camps in the local university, state university. And I met a lot of engineers there that were like my mentors and tutors, and they really inspired me to pursue engineering. I went from mechanical engineering to material science engineering because I just found it really fascinating. Like I didn't know what most of the words meant, but I was willing to learn. And you can see here in the corner, I made some really good friends. I was very close to them, and they're honestly the reason why I passed my major. And in the end, I did graduate with 2 certificates, honors, and my degree. And I really contribute that to the community I built when I was there because I was very involved in extracurriculars. Also a little bit more, I was super duper involved. I was a tutor. I would go to conferences. I would go to classes where they would teach me laboratory equipment. I would volunteer my time to really lift others up and kind of teach them that they can also be an engineer. And of course, I had several awards through that. So this is a competition for startups. So I created a company with these team members, and we won first place for our pitch. And in the left, this is an award that I received from the CEO himself for our contributions for my group called the Society of Hispanic Professional Engineers, and kind of contributing to their initiative of helping high school students work on what I think they call it like Legos teams. I forgot the name, but that was really cool to be able to help these students. Work experience. So I didn't start off in semiconductors. I actually worked for a defense company in California. A good thing about being an engineer and your internships, you get paid and compensated for moving. So I really enjoyed it. I got to live in California, even though it was a pandemic. I had my own car, I had my own apartment. They helped me move out with a lot of money. These are my friends that I met when I was working in the laboratories. And then I kind of missed home. And so I decided to come back, finish my last year of my bachelor's, and I actually worked in Fab 32. So here, this is the fab that I would go work in. And I really liked it. I thought that this was a lot more exciting than learning about weapons. So I really appreciated the opportunity to take part of this. Oh dear, I think I'm gonna have to stop sharing and start sharing again and share my sound because I want to share a video about what Intel does, kind of how we create a chip from sand to silicon. Let me know if you can hear it. Okay, perfect. Basically, we're like melting the sand to create really pure wafers. First have to be like 99.9% pure in order for us to create. And this is a lithography process. Every single industry competitor, and even Intel has different ways of pattering their chips. So this is one of the most fundamental parts. So here at Aloha, we do that. We slice them up and we send them to Vietnam. Our packaging is actually one of our best departments in the world, and a lot of competitors come to us to figure out packaging. And there we go. That's how we make a chip, and that's literally what powers your technologies, computer, the machine. Here. Oh, thank you for allowing me to share that. Other than that, my next slide is just questions, and I can leave that open to the panel once everybody's done introducing themselves.
Thank you so much, Cindy. So let's have Deepak.
Hi, can you hear me?
Yes.
Yeah, sorry, I got some update that I couldn't postpone and had to drop briefly. I'm sharing my video, but probably you can see having some issue there as well. But I think I'll just go with my introduction first. Hi, everyone. Good morning. My name is Deepak. My full name Deepak Giri. I'm originally from Nepal. Maybe you have heard about Mount Everest, a lot of mountains and Himalayas, kind of a hilly region. So I went to the school and the college and later did masters in Nepal and came to USA in 2011 for a PhD degree in chemistry. You may be surprised, I started my English language at grade 4, started alphabet there, and then kind of slowly learn after that. So I joined Kansas State University in Manhattan, for my PhD program, and graduate there from in 2016. My research was like the spectroscopy, looking at how the light interact with the material, kind of things. So I feel lucky enough to be able to get selected and join Intel in 2016. So I've been in the module. So we have like different kind of the department program, and I am a process engineer working in the fab, working on different technology to get these kind of the advanced chips out. So looking back, my school, my college, and like trying to connect to the job, getting here, I think it kind of makes sense if I look back in the retrospect. I still have kind of quite a bit of interest in the STEM, in the science, and that is what pushed me forward to learn more, get curious, ask question, and then kind of pursue the technology that I always kind of wanted to. So my kind of current role, I have to work on the process. It is kind of making some thin film deposition. There are kind of issues we have to deal kind of day-to-day or weekly basis. They could be kind of related to the material we develop or the tools that kind of that around those materials. So in terms of skill sets, it is really comes to understanding how the equipment run, what is the material in the process, all the data analysis techniques, those will come handy, and anything at the fundamental level, at the basic level that you can learn at the high school or later in the college, that will be helpful when you do the real job. So that's kind of a kind of a intro, and then onto my the current job kind of role. I don't know, we are open for the question, but yeah, please let me know if you have any questions.
All right. Thank you so much, Deepak. And I think we also have Bishwajit.
Yes, sorry, I'm just trying to turn on my video. Hi, can you hear me and see me?
Yes.
Thank you. Hi, this is Biswajit. I am an analytical engineer at Intel. You might ask, oh, what is an analytical engineer? So basically, we make chips, as Cindy showed us. So what does that do? Is like we put a lot of chemicals in the fab, and those chemicals go out in the atmosphere as like emissions. So we have to be compliant with the local and United States regulations. So we have to measure those chemicals, like what we are putting out over in the atmosphere, like CO2 and other things. So what I do, I use different analytical instruments like Fourier transform infrared spectrometer, or a flame ionization detector, or a combustion analyzer. So all kind of instrumentations. So these are the analytical instruments. So that's why the job title, analytical engineer. That's what I do in my day-to-day work. Little bit about myself. Yeah, like Eugene and Deepak, I also went to a school in a different country. I went to school in India, and then moved to the US for a PhD degree. And I always like chemistry, especially along with maths and science. But other than that, we had a lot of Star Trek and Star Wars, movies and series. So I really like lasers. Laser was my first first love. So that's why I went to do my PhD in laser spectroscopy, and ended up before coming to Intel, ended up going to California, worked in a national lab, did some research there. And I really always like lasers and its analytical problem solving, and ended up in Intel. And I really like my job here. What kind of problem do I solve? Environment is a big thing right now, right? And I don't know, we have announced 2040 rise greenhouse gas. So we'll reduce the greenhouse gas emissions to zero by 2040, and we're going to play a big role to achieve it. And we are making a lots of fabs around the world to support our IDM 2.0 strategy, which is basically making as much chips as possible. Because as you know, world is right now going through a really hard chip shortages. And we're trying to solve this problem by making more fabs. And as we make more fabs, we have to make our environment better, or not worse than what we have right now. So that's the biggest part that we play in this role. What makes me fit well in this profession? Well, laser analytical skills, and I really care about environments. Along with that, I really have to learn different things in different stages of my career. Like from lasers to even with lasers and analytical instrumentation. Right now, we have to do also modeling, and that requires a lot of software engineering, which I really didn't have any idea before I came here. So I had to learn those things. So like this kind of adaptability, like what you learn as you go. And you really have to love the the job that you are doing, and think like this is not a job, but what you are like, you get paid for. So I think that's the best advice that I can give to any students, or like any point of my life. Little bit about future forecast for our industry. I talked a little bit about IDM 2.0 strategy. Yeah, we are going to grow big. So we are going to have a lot of fabs, and environment will play a big role in there. So I think we are going to play a big role in there. Yeah, I think that's in short my introduction, and I'll happy to have any questions that you might have.
Thank you so much, Biswajit. And I think there's a big fab that's going to be open in Ohio. Is that right? Yeah.
That's
So
absolutely right.
yeah. And so let's go to questions. And my first question, and let's start again with Kelly. When looking back in high school, is engineering degree your first choice? And if not, what was it and what made you choose an engineering degree?
So when I was in high school, I mean, I went to community college even, and the only thing that I knew about related to computers was like typing. There was no computer science. There was no other like, I had no connection that there was like jobs associated with this thing. And so since about 6th grade, I wanted to be a teacher. I wanted to be a math teacher. My mom's a teacher and I like working with people. So I went to my university and I said, I want to declare my major as an education. And my mom's like, Kelly, don't do it. It's not worth the time. It's not worth the money. It's like, it's a much harder job and like, it's not going to be enjoyable. And I was like, Mom, I'm 18. You can't tell me what to do. I've wanted this like my whole life. Like, imagine somebody, especially your parents, saying like, you shouldn't or you can't do the thing that you always wanted to do. So I was very, very upset, but she convinced me. And I still believe this is true. The best teachers are ones who work in their field first and then go back to teach. So I was like, fine, Mom, I'll study math and then I'll be a teacher. So, but because I declared my major in math, which is STEM, I was offered a scholarship for women to study either math or computer science. And the only requirement was to take one computer science class and then major in one or the other, and they were going to pay me. And I was like, sure, I'll do that. I'll take your money. But I took that one class and I loved it. And I was just like, how did I get this far? I mean, it's like, how did I get 18 years into my life and not know that there were any jobs associated with computers at all? And that this is such a great thing for me because I love solving problems. Like I love doing puzzles. I love figuring things out. I'm not really a big like nerdy person. Somebody else mentioned like Star Wars, Star Trek. Like I'm not really that nerdy person, but I love solving problems and I love working with people. And with computer science, I was able to do that. So kind of since then, I like kind of made it a big mission to tell all these, like tell everybody else about it. I volunteer at things like this. I have gone back and taught before. I taught high school AP computer science and it was awful. Like it wasn't for me, but I still love solving problems and I'm so glad that I got into computer science. And it was because I majored in math, I was offered a scholarship because it's a STEM category. I was offered that. And it really stems back to like solving puzzles and working with people.
That's awesome, Kelly. Thank you. So let's go to Eugene. And if you want me to ask the questions again, I can.
Yes, actually, can you please ask the question one more time? I'm sorry.
Yeah, it's okay. So looking back, when you were in high school, is engineering degree your first choice? And if not, what was it? And what made you choose to be in the engineering degree?
Sure. Oh, wow. That's honestly kind of a difficult question, and I'll just be very straightforward with you guys. I knew that I liked science, and I knew that I wanted to apply science in one way or another. Um, both of my parents were engineers, so part of it, they were like, "Hey, like we made this awesome career out of engineering. You should too." But at the same time, when I was a little bit younger, I was like, "Hey, maybe I should start my own path." And try to do my own thing with science. So I actually wasn't originally targeting engineering. Truthfully, when I was in high school, I was actually thinking maybe like medicine, and I was like, hey, maybe I could use science, to help people. What I ended up figuring out, like as I started learning, like what medicine is really about, um, you have, at least in my opinion and from my experiences, you have much greater chance of changing things and doing good with engineering than you can with medicine. And I started seeing that like engineering lets you use math and science more practically and with more proven results. Not that medicine, you can't do that, but medicine has so much to it. I spent some time in the hospital, and I kind of came to the conclusion that modern medicine is still kind of a big mystery. And from an engineering point of view, in engineering, you can solve problems, you can create solutions, and it's just a little bit more concrete. So that's what I appreciate about engineering. It's the fact that you can use science and math to come to like concrete solutions and to solve problems. And that's my story on that.
Thank you, Eugene. So let's have Cindy.
Okay, so what in high school gave me the ability to do engineering? Well, originally I wanted to be an aerospace engineer because I really like space. I like took time to look at documentaries about space. So I was like, maybe that's within my forte, but I was told by my counselor, like, you have to be careful. You're Latina, you're a woman, there will not be a support system for you. And so I was like, okay, logistically, I should maybe look at a major that is a little bit more broader. So I chose mechanical engineering, and that's what I came in college as. I just knew I liked science and math. I was like a whiz at math. I was terrible at science. But I kind of came in, mechanical engineering was cool, but there's something that didn't feel right. I really didn't care for designing stuff, nor did I have the creativity. So I went to my counselor and I was like, oh, this isn't meant for me. Can you give me all the major maps you have of every single major in this school? And so I kind of like sat down, looked at everything, and I was kind of like, what sparks my interest? And that's when I found material science, and I really didn't know what it was. And many people don't. So I really do have to go out of my way to advocate for myself that I am just as capable as any chemical engineer or like electrical engineer, just because my degree is so applicable to everything. It really just depends on my skills if I can get the job. So yeah, that's kind of what happened in high school. It helped that I loved challenging myself, and I did like the International Baccalaureate program. I passed. That's what matters. I wasn't excellent, but I passed. But I think that challenge during high school set me up for the persistence that I needed for engineering. I hope that answered the question.
Yes, it does. Thank you, Cindy. I just want to remind students that if you have questions, don't be shy and put it in the chat. So, because this is a really good time to ask this engineers. So let's go with Deepak.
Hi. So thank you. So touching upon the question whether I thought of engineering career back in school. So really back in school, I kind of wanted to become a doctor. I, kind of got fascinated, passionate how doctor able to, cure the sick people and then make them, kind of get out of it, happy sort of things. So that was the kind of the more interest in school. But later, as I kind of started the college, I got really kind of interested more in the chemistry side, in the sense that it connects to everywhere. I can't think of anything that is not connected to chemistry kind of things. Then I kind of pursued more on the chemical sciences sort of things, and later graduated with that. And then, like looking back, kind of going for the medical, the profession versus the current. I think it was kind of personally, I felt like a good choice. I kind of got to what I kind of wanted, or from the college sort of things. Yeah.
All right, thank you, Deepak. So let's have Bishwajit.
Hi. Yeah, well, no, I never thought of doing engineering during my high school. like Deepak, I was good at chemistry and always wanted to do chemistry, and that's what I did. But while learning chemistry, you need to learn a lot of physics and maths as well, because chemistry, I mean, some branches of chemistry, they don't go well without learning physics and maths. I mean, sure, you can like understand some of the reactions and things like that, but in order to understand physical chemistry, or that was my biggest interest was. So that's what I did, like maths, physics, and chemistry, but not any engineering as such. And but what I learned didn't have any problem to apply those skills to any engineering set as well. So that's what I think, because we have to make a lot of instruments, which requires, or we don't make it actually, but we set up things the way it needs to be engineered. It's not like off the shelf instruments, so we basically have to make those or like engineer those. So that was never a problem. I could always apply my skill set to the things that I do right now.
All right, thank you so much. So now that you are engineer and working in the field, have you ever faced a challenge that made you think that this career is so hard and might not be for you? So how did you overcome that challenge? Let's go again with Kelly.
I would say like most days, because really how it works is, especially when I was on the software team, we would work in what's called 2-week sprints. So we'd work for 2 weeks on a project, and then like we'd work for another 2 weeks on like the next thing. And at the beginning of each of those 2 weeks, I'd look and be like, okay, Kelly, you're assigned to make this thing, do this. And I'm like, yeah, I understand the words that you're saying. Theoretically, that is possible. I have no idea. So it was every single 2 weeks. It was like I'd start and I have no idea if it's even possible. But I'd work with the people on my team. I'd be mentored by people on my team, mentored by people outside of my team, do a whole lot of Googling. And then like at the end of the 2 weeks, somehow like it worked. Like I was able to pull it off because I was able to learn so much every single time, and like learn how to put all these pieces together to make it achieve the result. But it was pretty much every single time. Every single start of the sprint, every single start of those 2 weeks, it'd be like, I don't think I could do this. This one's too hard. Like that's a really big ask, and I don't know what any of those words mean. So yeah, that happens all the time. I'm sure there's like much larger scale things, but like that's a little one that is a regular occurrence.
Thank you, Kelly. So let's have Eugene.
So I'm going to take a different approach here. So it's one thing, to be really smart, and it's one thing, to be a really good engineer, and of course that's very important. But there's the other side of it as well, and that's who you are as a person. And I think some of my challenges have been, I've met some truly smart and exceptional human beings in my engineering career. But sometimes, the knowledge and the ability to translate that knowledge kind of gets lost in communication, or just sometimes just in personality traits. So part of my challenges has been to, um, learning how to communicate with everybody to make sure that, we're all on the same page when it comes to progress. And making sure that in addition to having this awesome amount of knowledge, that you also have this personality that is aimed at doing good, especially with that knowledge. And sometimes you don't always find that. So sometimes in this position, you have to kind of balance your personality and your knowledge and how much you know as a person to get effective work done and to be the best engineer possible. So that's kind of just my challenge that I wanted to put out there.
Thank you. So let's have Cindy.
Could you repeat the question again?
Have you ever faced a challenge that made you think that this career is hard or not what you thought it would be?
Mhm.
And how did you overcome that challenge?
Well, I think that's for me, not being able to see someone of that looks like me, really does like mess with you, I guess, imposter syndrome. And so that was something that I struggled with throughout my engineering career in academia while I was getting my degree, and even now. Sometimes in here, like everything's so fast paced and accelerated, I just really go to a lot of the experienced engineers and new engineers and ask them for advice. And everybody's very much willing to help you along the way. And eventually you figure out that like nobody knows what they're doing. We're just trying the best we can. So I think that is a huge component that I really liked about the Intel culture. Um, Everything is so revolutionary and it's not even thought of. It's like maybe we can make it work. Um, it is very stressful, but I like that the community here is like more than willing to help you out and take care of you and is willing to give a lending hand, but also like I've had to put a lot of effort and time into learning this aspect of my job. So there are many times where when I think I'm like, oh, this isn't for me, I'm not cut out for it. But in reality, it's just everybody else is feeling the same way since it is such a high pressure job and it's so fast and so quick and evolving. Um, so yeah, it takes a lot of personal growth and a lot of social growth as well, which is really hard for me because I have like a disability. And so like it's hard to figure out some social cues. And so definitely like Intel is one of the better companies, I think, in my opinion, about having that culture and having so many resources that it really is up to you to reach out.
Cindy, if you don't mind, is it okay to ask what is your disability? Because maybe the students will some have it too, and like it's not gonna get discouraged in being an engineer.
Yeah, I guess like so I have major depressive disorder and major anxiety disorder. So one thing about Intel is that they're very open about disabilities and they're willing to help you out and give you the time you need to relax. I get unlimited sick time, so that's kind of nice. And honestly, like it has been a struggle because my disability just it's a chemical imbalance. And I know that is that the chemical imbalance really counts towards negative perspectives that I have. But I've had to really learn more about people, social cues, and kind of what could be happening in their moment in time that they're talking to me like this. So like that has been a learning curve that I've had to learn. And I have resources. I have really good health insurance, thankfully, to Intel. Even as an intern, they gave me healthcare. And having that resource has just made the quality of life that I have much better. So yeah.
Thank you so much for that, and I totally understand. I have a major anxiety, and it's affecting my body because I get migraine if there's a lot of people, and it's
Yeah.
it's a journey that we have to go through and overcome that. Okay, so let's have Deepak.
Hi. Yeah, thank you. That's a great question. Yes, of course, not one, but several times I had that feeling, kind of it's, there will be kind of challenges, all the time. Many of the colleagues mentioned, it's kind of a fast-paced environment. There are technical challenges, there are people challenges, getting everyone, getting them convinced to fix the issue. But as you work on the problem, as you work with the people, you kind of develop this, instinct of perseverance, and this is a great company, to work. Many, talented folks who are always willing to, support if you seek for help. So yeah, it's a journey, and I think yes, I felt that way. Maybe it's not a right job given my, despite my interest in the engineering side of things, but as you work towards the problem, you kind of get built upon the people skill sets, the technical skill sets, and you slowly overcome, and you kind of go into a space where there will still be challenges, but you may not necessarily feel the same way that you feel in the first few years, kind of things. Yeah.
All right, thank you. So let's have Bishwajit.
Yeah, that was a really great questions and great answers, like all the communication skills, listening to the people talk, work as a team. These are all like great answer, and that I faced all of them, and thanks for those answers. One thing I'm just going to add to this answer is, so coming from a different country, here it was like at Intel, what I liked the most, there are so many brilliant mind works here, and they are from different countries, different religions, and like so much diversity in here. And I think Intel appreciates it a lot, and I learn every day with like this different people. And I think that's a great add-on to like any kind of like company or any kind of problems you are going to face or solve. So I think that's the only addition that I can add to all these answers.
Thank you. So we have a question from one of the students. I think this question will go to the engineers that work in the fab, and I'll let you, just whoever wants to answer, is from Bill Todd. During the pandemic, when you work in a bunny suits, was it safer for you to go to work because of how sanitary it was?
I guess since I brought up bunny suits, I can talk about it. Yeah, I felt safe going into the fab, but also Intel was very strict about their guidelines about who could go in and who could go on site. And even then, they were even more strict on the mask mandate and really strict about social distancing. And if you did get COVID, as exempt workers, we had unlimited, full-time basically, we had unlimited sick time leave, but anyone that wasn't our category of full-time, but was a different full-time, they got extra COVID leave on top of their regular vacation and other stuff. So it was really nice to see that they were more than willing to make those accommodations for something that basically affected the whole world. So yeah, that's my take on it.
Maybe I can add a bit to Cindy. Thank you for the question. So my job is also kind of related to the fab. The tools that I work are inside the fab. So as the pandemic began, Intel added some additional infrastructure that allowed to remotely connect to the tool from the home. So unless it was like the absolute need, we had to be in the fab, to work on the tool. Most of the time, like later, kind of the mid-pandemic, after 5-6 months, we were provided with those tools. We could kind of check on the, on the equipment remotely on a day-to-day basis. So that was a great kind of add-on. Yeah. Thank you.
All right. So students, if you have questions, just don't be shy and put it on the chat. And otherwise, we'll like the time. So right now, my question would be, what is your advice to students who also wanted to be an engineer, and how can they excel in this profession? So we'll start again with Kelly.
I'm just going to echo what Cindy said, where she said that she attended different camps. Agreed, fully agree. Because camps are like a low-key way of trying something out before you invest a bunch of money in school and declare your major. And you can always like declare a different major and change your mind. But it just sometimes when you declare a major, it feels so permanent sometimes. Whereas a camp, trying it out, any sort of opportunity to try something out, do that. And one example is even when I was in school, there was this hackathon. If you guys get to do hackathons, that's great too. Or like a pitch fest where you do like a small startup in a weekend, like come up with some idea of what sort of business you might want to create. And then like you pitch your idea to possible investors. And whether it's real or not, I did one of those and it turned into a business, and the business has since like fallen under and it's gone now. But the opportunity to try that's something like I can say now, and it's on my resume now. Yeah, I started a business. It only lasted like 48 hours or like it only lasted like a year or two until it like officially fell under. Another one I did was a math competition, like mathematical modeling. And I had never really heard of that before, but it's this competition is like 48 hours long. You stay up all night and do it. Okay, so I did that over a weekend. And when I went into my interview for Intel, I actually like didn't even interview for Intel. I sat down for lunch with somebody, and it happened to be the right person who happened to be hiring. And they said, oh yeah, so I work on modeling. And I was like, oh yeah, I did a modeling thing like a couple of years ago. I did this modeling competition, and I could remember, oh, it was about this, it was about this. I used this language, I think, and we modeled this, and this was the outcome. And he was like, yeah, that's exactly it. That's exactly it. I'll hire you right on the spot. And I was like, okay, I don't really know any of those words anymore. I did it for 48 hours, but because it's something that I invested a very intense small amount of time to learn something, I can then reference it in the future. And like that's honestly how I got my job, is just trying something out. Because the other thing I want to mention is, especially whatever you do, you're going to college and people say, what do you want to major in? Or even as soon as you graduate, I graduated with computer science and math, and people say, what field of computer science do you want to go? And I was like, I have no idea. Like whatever they'll pay me to do, I'll do that. Like literally anything. So, but there's so many options. And even when you're applying, they say, oh, do you want to do big data? Do you want to do machine learning? Do you want to do the AI? And I was like, I don't know really. I don't know. So if you can try those out, do it. If you have an opportunity to take a class or like something that's a little bit different, but like sounds interesting, that's what I would recommend.
Thank you so much, Kelly. So let's have Eugene.
So I think there's two parts of it. I think the first part of it, and this is kind of echoing Kelly, it's being inquisitive. I once heard the phrase that the best engineer is the one who's always asking questions, and I think this is really true. Like having wonder and having curiosity can really help you out to being the best engineer. And even some of the best engineers who know so much, they come to these meetings and the entirety of the meeting, they're just asking questions. You know, I don't know this. Can you clarify this? So asking questions and being of an inquisitive nature. And then the second part of it, and this is something that I've already kind of echoed, but the willingness to do good. So the willingness to use, you know, math and science to achieve something great. I think that's the other part of it too. And that's my answer for it.
Thank you. So let's have Cindy.
Can you repeat the question, please?
What is your advice to the students who also wanted to be an engineer, and how can they excel in this profession?
Like Kelly said, summer camps, amazing opportunity, very low investment. And usually there are some programs that pay for you to go to summer camp. So the summer camp I went to, fully paid. I got the dorm, the food, everything. So that was really cool. And I think that was like the major lifting point. Like I tried data, I tried life sciences, I tried business. I hated all of it. I like space exploration. I was like, that's a good start point. And honestly, that was the major catalyst to me going into college. And of course, in college, don't ever stop trying or questioning if you like something, because at the end of the day, you're dedicating most of your life to this career. This is going to be the thing you wake up the next morning, stay like 8 hours every single day, and work. So question and ask yourself, if somebody asked me at 3 a.m. to work on this thing that I'm doing my career in and my degree in, would I do it? Then that's your answer. Yes or no will allow you to figure out your future path. So that is my advice. And going based off the question in the chat, can you take too many classes? Yes, you can. I failed 3 classes by taking 20 credits. Don't do that. There is a limit. You do have a limit. You guys are human. So just treat yourself with kindness and really ask for help. I know it hurts your pride and your ego, but one of the best engineers is the one that asks questions and asks for help. That's really it.
Thank you, Cindy. That's really good advice. So let's have Deepak.
Hi, thank you for the question. So I think camps are great. Personally, I do not have much experience with the camps, but I have a kindergarten, and I am having him start his first camp this summer. So hopefully you'll enjoy and kind of learn things there. From my personal perspective, I think getting the interest in the engineering, the world is kind of built upon engineering, all the technology sort of things. So there are so many day-to-day activities, tools that we come across. So if we kind of stop a moment, don't take things for granted and think about it, with a fresh perspective, what it is, what it does, where it come from, how it could have been built, that once you have that question in mind, then it triggers, question after question after question. And maybe that is a way to, get interest, build interest, and find the things, that you really kind of passionate about.
Thank you. Okay, let's have Bishwajit.
Yeah, great answers, everybody. And I just wanted to add on to that. You can get internship as well, along with camps. And you don't have to even go for engineering internship. You can ask for tech internship, like technicians, because some of the great engineers that I know, they are really hands-on. They can do stuff by hand, like, and when I asked them, oh, what did you do? And then they said, oh, I just did hands-on experience with this so and so instruments, and then they can basically build things ground up, like if you give them those things. And I think from high school students, you can go to some of the college, get an associate degrees, and then you can even join Intel as like a tech intern and do like part-time internship there. I think that would be a great addition along with those things.
All right, thank you so much. And so it looks like our time is up. And I want to say thank you for the students for being here, and our panel of engineers for taking their time. And I know you guys are working. My husband works at Intel and he works like so crazy. So thank you so much for being here and offering advice and helping students choose a career that they want to be in. So thank you.
Yeah, thanks.
Yeah. So students, if you want to say thank you, you can turn on your camera or you can put it in the chat. So it's nice to tell the engineers to, we appreciate them being here.
Thank you so much.
All right, I'm going to stop the recording.